All right, guys, we're going to start lesson 7, ratio and rate problems. This is the last lesson for chapter 1, and after this we start chapter 2, so yay. All right, so let's just get to it. The question, as always, has been, how do you use equivalent rates in the real world? Hopefully you've been seeing that we've been doing that this whole chapter. We have 2 goals for this lesson, and it's stuff that you should already be familiar with. Number 1, we're going to solve ratio problems, and number 2, we're going to solve rate problems. They are different. We're going to talk about that a little later. All right, goal number 1, we're going to solve ratio problems. The goal is to use bar diagrams or equations with equivalent ratios to solve ratio or rate problems. Okay, so if you go to page 72, I believe. Now I realize some of you may not like the bar diagram, and that is your choice. I will show it to you. If you like it, great. If you don't, use another way of getting it done. As always, math has many ways to get the answer, but you got to do the work either way. So page 72, number 2. The question states, the ratio of the number of text messages sent by Lucas to the number of text messages sent by his sister is 3 to 4. Lucas sent 18 text messages. How many text messages did his sister send? Okay. As always, before you do the math, I know we see the ratio 3 to 4, but 3 to 4, I mean, you want to write it down, that's great. At least get something down. We're talking about a ratio of 3 to 4. 3 to 4. But what are we talking about? 3 to 4 of what? You know? You have to put words with it. So, the ratio of number of text messages sent by Lucas to the number of text messages sent by his sister. Okay, so we have a guy named Lucas. I'm assuming it's a guy. Lucas and his sister. Again, ratios, it's a relationship, a connection. So for every 3 that he sends, she sends 4. And I don't know why I wrote 5. Apparently I can't count. So if you caught that, good for you. I'm glad I caught it, because that would have been really bad later on. 3 to 4. Lucas to his sister. Alright, we're going to use a bar diagram. Now again, you might not like it, but it does have its advantages. Okay? 3 to 4. Alright, we have, it's going to sound really weird, 3. Now the book does it a little differently. You can do it the way the book does it, or you can do it the way I do it, but in the end, you're going to have to figure out what works best for you. Okay, so anyways, boxes, or bars, 3 bars. 3 bars for every 4. Lucas, sister. Alright, now here's the situation. We have 18 texts, right? How many texts does his sister send if Lucas sends 18? So Lucas sent 18. And I'll put that on the side. Lucas sent 18 texts. The question then is, how many did his sister send? Okay. Now here's the thing about the bars. Okay? The bars are supposed to be equal. And, put that on the side here. Bars should be equal. All right? So, here's the deal. We have 3 bars, 3 groups, right? 3 groups. So the question is, how much is in each group? Well, now it just sounds like a division problem, doesn't it? 18 divided by 3 groups. Now, I'm just going to go ahead and do the math. 18 divided by 3. If we have 3 groups, that means each group has to have 6. Okay, at this point, guys, you really got to know your times tables. Alright, so I'm going to redraw this. All right. If Lucas is 18, and each one's supposed to be 6, right? That's 6, 6, 6, that's 18. And the sister, well, how much will she have if it's 6, 6, 6, 6? That's 4 groups of 6. 4 times 6, that's 24. Okay. So the answer then is his sister sent 24 texts. And again, you must write complete sentences. Okay, you're middle schoolers now. That's just the way it goes now. All right, the other way, of course, is equivalent fractions. Okay, so I'll do that on the side. All right, same idea. 3 to 4. Lucas' sister. Again, the relationship, for every 3, she sends 4. That's just the way it worked out for this person. So I'm going to rewrite it again. Ratios, this is a ratio. Okay. It's not a rate because we're not measuring anything. Okay, we're just counting, so that's no big deal. All right. If we know Lucas sent 18, how many did his sister send? Okay. I'm going from 3 to 18. I am scaling up. That means I'm going to multiply. That means I want to know how many groups of 3 do I need to get to 18. How many groups of 3 do I need to get to 18? Or, of course, you could say it, if I have 3 groups, how much do I need to have in each group to be 18? Whatever works for you. But you know how I like saying it? That's just me. So I'm scaling up. How many groups of 3 do I need to get to 18? Well, I'm going to multiply then. And like I said earlier, I'm going to multiply. I'm scaling up. And since they're behaving like fractions, because that's what ratios do. They're not fractions, but they behave like it. Whatever you do to the top, you do to the bottom. Whatever you do to the bottom, you do to the top. Numerator, denominator. 4 times 6. Oh. Psh. His sister sent. You ever do that? You're writing a sentence and you skip a word. You think it in your head, but you don't write it down. His sister sent 24 texts. And that's it. Again, you use whatever method you like. Both are equal in my eyes. You just do whichever one works best for you. All right. So now we're up to page 73. Got it? The A, right? A. In a survey, 4 out of 5 people preferred creamy over chunky peanut butter. There are 120 people shopping at the grocery store. Use the survey to predict how many people in the store would prefer creamy peanut butter. Okay. Now, I showed you 2 ways of doing it. You can use equivalent fractions, or the bar diagram. Now, my personal preference is the ratios, equivalent fractions, equivalent ratios, because I understand what I'm doing. And that just comes with experience. Not because I'm smarter than you guys. I just know more. I've been doing this longer. All right. But first things first. 3 out of 4. I'm given that ratio. But what does that mean? 3 out of 4. Oh, and you know what? Apparently I can't read. Guys, I don't know what is going on with me tonight. It is late. Right now it is about, I want to say 8 o'clock. I've been up since 5. Just a little tired, guys, so excuse me, forgive me. 4 out of 5. But I do want to say this, though. Since I read the problem, again, just to verify, I caught my mistake. So maybe that should be a good lesson for all of us. Once you write the numbers down, just go ahead and take a glance at the problem again, just to make sure you copied everything correctly. Because if I had written 3 out of 4, the answer would have been totally different. And in this case, it would have been wrong. Okay, 4 out of 5 people preferred creamy over chunky peanut butter. Okay, we're talking about creamy peanut butter. I'll put down creamy PB. Now the denominator. I know it said creamy out of chunky. You might be tempted to say, oh yeah, it's creamy peanut butter over chunky peanut butter. But is that really what it is? Why would I think that? It does say it, right? 4 out of 5 people prefer creamy over chunky peanut butter. Something about that bugs me. I'm going to erase this for just a moment, and if I'm incorrect in what I said, I can always fix it. All right. 4 out of 5. 4 out of 5. Okay, so I'm going to draw my 5 people. 1, 2, 3, 4, 5. 4 out of 5. 4 out of 5. 4 out of 5. Creamy. PB. Now, out of 5. 4 out of 5. That means 5 is a total. 5 is a total. Oh, okay, that's what bugged me. Okay, so 5 is a total. I hope you see how I got the total. Okay. Literally. 4, if you take it out of the 5, that's how that works. Like creamy peanut butter. But you know what, since we're here with this, what about this little guy? What's that? What does he need, or what does he want? Well, we're talking about peanut butter, and it looks like we have two kinds. Excuse me. Two kinds. We have creamy, and I guess this would be the chunky guy. So, this would be the one guy that likes chunky peanut butter. Okay. That's okay. Alright, but it's not asking for this, but since I'm here anyways, why not do it? I will fix the color. It looks like... It's supposed to be purple. But regardless, so 4 out of 5 like creamy peanut butter. Alright, I'm going to go ahead and do the fractions. If I can do it quickly, then I'll just stick with that. Alright, 4 out of 5 like this. Again, there's my ratio. I'm treating it like a fraction. It says if there are 120 people shopping at the grocery store, use a survey to predict how many people in the store would prefer creamy peanut butter. Okay, I see that number 120. Now, it looks to me like it's a total. If you have 120 people, if you can imagine 120 of these, right? Groups of 5, keep 5 till you get to 120. Well, the question is, how many people like this creamy peanut butter? Well, okay, same idea. I'm noticing I can scale up from 5 to 120. If I'm going to scale up, that means I want more groups of 5, right? How many groups of 5 fit in that 120? Alright, so 5 times something, right? Or how many groups of 5 fit into 120? It sounds like you're saying 5 is a dividend and 120 is your... Oh, excuse me. My goodness. It sounds like this would be the divisor. This is the one cutting. We want groups of 5. Groups of 5, I apologize. 120 would be the dividend. We're cutting this up. Well, let's do the math. Alright, making groups of 5. I can't make groups of 5 from 1, but I can from 12. I can make 2 groups. That gives me 10. I have 2 left over. Bring down the 0. 5 times 4, 20. Alright. So it looks like I can get 24 groups of 5 to get to 120. And like I said with the other problem, whatever you do to one side or one part, you do to the other side. It's really not a side, right? It's top, bottom. I'm telling you, I think I need a nap. So, 4 times 24. I mean, I already did it in my head, but just for the sake of argument, 4 times 4 is 16. Carry the 1. 4 times 2 is 8, plus 1 is 9. 96. But again, don't just write 96. 96 what? What does that 96 mean? You gotta write a sentence, people, and I'll write it for you. It means 96 people prefer creamy peanut butter. Now, why did I hesitate earlier? I was tempted to write 96 people out of 120 prefer creamy peanut butter, but that's not necessary. It's just asking how many people like the creamy peanut butter situation, so I just went with that. All right, letter B, excuse me. Same page, but now it's letter B. A survey found that 12 out of every 15 people in the United States prefer eating at a restaurant over cooking at home. If 400 people selected eating at a restaurant on the survey, how many people took the survey? Ooh, okay. All right. All right, let's see what we have. We definitely have the ratio 12 out of 15. Okay, at least we got that down. We got the numbers down. But what does the 12 and what does the 15 refer to? What are we talking about? What are we comparing? Yes, 12 to 15. But what? 12 what? 12 dogs is 15 cats? No, let's see what we have. 12 out of every 15 people in the United States prefer eating at a restaurant. Eating at restaurant. Cooking at home. Now, wait a minute. Does that look right to you? Does it say that 15 people prefer cooking at home? Do you think this might be a total again? I think that might be a total again. Now, I could draw a picture, but I think by now, I think you get the idea. 12 out of 15. And it's in the words, 12 out of 15. So I think this is a total as well. Just like the other problem. So, if you go too fast, you will make mistakes. So, you know what? I have to admit, I was going a little rushed. I was going a little bit of a hurry. Slow down. Do it right. All right. 12 out of 15 people prefer eating in a restaurant over cooking at home. All right. If 400 people selected eating at a restaurant on the survey, how many people took the survey? Oh, all right. All right. So let's make sure we got this right. 12 out of 15 people. 15 total. 12 people out of that 15 total prefer eating at a restaurant. Fair enough. I'm going to treat them like a fraction. 12 out of 15. Now it says here, if 400 people selected eating at a restaurant on the survey. Okay, all right, there we go. I don't know if that'll work, but we're going to find out right now. How many people took the survey? So we're looking for a new total. We're looking for a new total, right? And I'll put it up here so you can see what I'm talking about. 400 people eat at a restaurant. What's the total? Okay, now, here's the situation. Off the top of my head, I can't think of any whole number I can multiply by 12 to get to 400. If you can, you're great. You're awesome. I can't do it. But when that happens, if you remember, if you can't scale up directly, maybe you have to simplify. Maybe you have to scale down first. Let me try division. Let me see if I can make this smaller for myself. All right, 12 and 15. They have a common factor of 3. I can make groups of 3 out of both of them. Right? I know I can do that. That leaves me with 4. 4 times 3 is 12. And then this leaves me with 5. Okay, this will work. Now, this is lesson 7, guys. I'm not going to explain why this works. We did this in lesson 1, lesson 2, lesson 3. Look back at your notes if you're not sure. Look back at your math book if you're not sure. But all I did was I simplified. 12, 15, I couldn't scale up. That means I scaled down. That means I'm going to try scaling down, see if that works. And it works out that there's a common factor, which is 3. Is it GCF? I believe it is. But I got lucky. I just guessed. 4/5. Boom. Now, oh boy, I can see now that I can scale up. If I have groups of 4, I can make 100 of those to get to 400. And again, like I said before, whatever you do to the bottom or whatever you do with one, you do to the other. Well, that makes it easy. That makes this 500. But again, 500 what? There were 500 people in the survey. Okay, and that is goal number 1. Okay, we're now up to goal number 2. We're going to solve rate problems. This time we're going to use double number lines or equations to solve rate problems. Okay, you might have heard of double number lines before. I don't remember if I covered it or not. But either way, I'm going to show you what it is. It's not so bad. This is page 73, example number 3. Okay, the Millers drove 105 miles on 4 gallons of gas. At this rate, how many miles can they drive on 6 gallons of gas? All right. It's the way the book does it, they draw one number line. One number line. You guys have all done that before, no big deal. But instead of just adding numbers, or instead of just adding numbers, you also have to add words. Okay? What are we comparing? We're talking about miles to gallons. Miles to gallons. Okay. And here's the deal. You always start at 0. 0 miles, 0 gallons. Now the ratio they give us a ratio of 4 gallons. So I'm going to write this down. 1, 2, 3, 4. And with 4 gallons of gas, they tell us this car can go 105 miles. 105 miles, 4 gallons of gas. And then, of course, the question is, at this rate, how much can they drive? How far can they drive on 6 gallons of gas? So I'm going to go to 6. How far can they go on 6 gallons of gas? Oof, all right. Here's the situation. To go from here to here, not very easy. Unless you're a genius. I'm not. So it looks like I have to figure out, okay, I don't know how many miles per gallon I get. So I'm going to have to find the unit rate, right? And you're going to see in just a moment that really what you're doing, you're doing equivalent fractions, but I'll show you that, and I'll show you what I mean in just a moment. All right. To go from 4 to 1, let me make this a little darker because you might not be able to see that it's actually 4. To go from 4 to 1, I have to divide by 4. 4 divided by 4 equals 1. That means I have to divide this by 4. Now, heads up, you're going to get a decimal number. Not a big deal. 105 divided by 4. All right. 4 times 2 is 8. Subtract. You get 2. Bring down the 5. 4 times 6 is 24. Subtract. Bring the 1. I have 1 left. I'm going to have to break it up into parts. So I add my decimal point. Decimal point, add a 0. Bring that down. I can make 2 groups of 4 to give me 8 out of 10. I subtract. Add a 0. I can make 5 groups of 4. Give me 20. I stop right there. All right. So it looks like I can get 26.25 miles per 1 gallon. Right? Now here's where it gets weird. Now we got to go from the 1 all the way to the 6. Now how do we do that? We're going to scale up by 6. You multiply by 6. That means you're going to multiply this by 6. All right. 26.25 by 6. Now I realize some of you have problems with this decimal point. It freaks you out. It's just a dot. For right now, it definitely means more than just a dot. But in your head, for while you're doing the math, just think of it as a dot. It's not there to harm you. It's just a little dot. Just do it. Do the math without the dot in your head, okay? 6 times 5 is 30. And you know what I'm going to do in pencil in case you make a mistake. 6 times 2 is 12, plus 3 is 15. Carry the 1. 6 times 6 is 36, plus 1 is 37. Carry the 3. 6 times 2 is 12, plus 3 is 15. All right. But remember, we still have the decimal point. Different decimal point. I have 2 place values. 1, 2. To the right of the decimal point. So I'll do the same thing here. 1, 2. Put the decimal point right there. And that's my answer. 157.5. You don't have to write the 0 if you don't want to. But again, you can't just leave it like that. You have to write a sentence. The car can go 157.5 miles. And that's it for that. All right. We're going to do the got it on page 73. You know what? Just for the sake of argument, I'm going to show you the equivalent fraction just in case you want to see, because you're like, can we do it another way? Yes, you can, actually. Okay. They give us the fraction, or the ratio 105 to 4 miles per gallon. All right. This is what we don't know. But we want to know how far we can go in 6 gallons. You're looking for a unit rate then, basically. Right? You want the denominator to be 1, so we know how many miles per gallon. Divide by 4, divide by 4. We already did this, and the answer was 26.25. Right? So the car can go 26.25 miles per gallon. Again, miles per gallon. And then you can do this. And that's really all you did. 157. I'm going to type it outside the box so it's not squished. Same answer. Again, if you don't like the line diagram or you don't like the bar diagram, don't do it. I like it because in some sense it gives you a guide. Because really what you just did, this is a ratio table if you think about it. Right? But, you know, hey, you pick whatever's best for you. All right. On to the other problem I mentioned, the got it, letter C. This is page 73, same page. Look at that. All right. There are 810 calories in 3 scoops of vanilla ice cream. How many calories are there in 7 scoops of ice cream? Ay, Dios mío. Okay. All right. 810 and 3. Those numbers go together. 810 calories. 3 scoops. I'm going a little faster because you should be able to keep up. All right. I'm just going to go ahead and do the fractions because I'm not a big fan of the upper number line. It just seems like it's wasted effort. I don't need it. But if you need it, hey, at the beginning I needed it and I used it. But I'm not there anymore. I've moved on. Okay. Anyways, we want to know how many calories there are in 7 scoops of ice cream. Vanilla. Okay. Same thing. I can't think of any whole number I can multiply by 3 to get to 7. I can't. I mean, again, if you can, then you're awesome. I can't do it. So I'm going to see if I can simplify this. I'm going to divide this by 3, see what I get. May not work, right? Well, I know this 3 divided by 3, I know is definitely 1. That definitely works. But this is the one that's going to be a little hard. But not really. Step by step. You're making groups of 3. How many groups of 3 can you make out of 8? 2. Because you know times tables, right? 3 times 2. Bring down the 1. How many groups of 3 can you make out of 21? 7. Up. And we have a 0. Bring down that 0. How many groups of 3 can we make out of 0? In other words, if we want nothing, how many groups of 3 do we need to get to nothing? Well, nothing. There you go. All right. 270 calories. Right? Per scoop, which makes sense. Okay. Now I hope you can see that from here we can scale up to 7 if we multiply by a factor of 7. Right? And we do the same thing at the top. We're going to do a little math. 270 times 7. 7 times 0 is 0. 7 times 7 is 49. 7 times 2 is 14 plus 4 is 18. And there's your answer. But again, you need a complete sentence. 1,890 calories for 7 scoops. So that's what I'm going to write. There are 1,890 calories in 7 scoops. And I think that does it for the... Nope, there's one more. Got it. Excuse me. If you go to page 74, there's a got it right there. All right. While resting, a human takes in about 5 liters of air in 30 seconds. At this rate, how many liters of air does he take in during 150 seconds? Okay, all right. 5 to 30. 5 to 30. 5 to 30. But 5 what? 5 liters of air. And 30 seconds. Okay. There are my numbers. There's my ratio. 5 to 30 liters of air, seconds, part to part, right? I'm going to treat them like fractions. All right. Well, the question is, how many liters of air does he take in during 150 seconds? All right, 150 seconds. How many liters of air do we take? All right, this actually shouldn't be so bad. 150. All right, to go from 30 to 150, well, how many groups of 30 do you need to get to, how many groups of 30 do you need to get to 150? Well, how many groups of 3 do you need to get to 15? 5, right? And that's it. Because, again, 5 times 0 is 0. 5 times 3 is 15. Done. Do the same thing at the top. 25. The last part is a sentence. Okay. He takes in... And it shouldn't even be he, it's just a human, I guess. He takes in 25 liters of air. And that's it. Excuse me. And that's it. Awesome. Hope it made sense.